Okay, so you had two puzzles. That's a great way to think about math problems, as honestly they are kind of like puzzles, especially the thing that we'll be doing later. But they involve side lengths and areas of rectangles, and you need to find the missing area in figure A and the missing length in figure B. Table 5, what would be the missing area in figure A? Did you say 1? Oh, 20. So 20 inches squared, and how did you get that? Okay. How did you know that this longer side was 10? Okay, so just kind of eyeballing it. Okay. So there is some instructions on your ACT Aspire that say that diagrams are not drawn to scale. So that means that you can't just assume, although sometimes you might assume right. Um, you have to use all the other information that's given and then confirm. Like you can't just say, oh, that looks like about half a floor because you don't really know. It could be like community decimal. But you do have enough information to know that it is a 10 by 2 rectangle. First, you'd probably find this side, and you know that for this, and their squares are also rectangles, but we know like rectangles have their opposite sides the same. So we know that from here to here it's 8. But then you're gonna have to confirm that this from here to here is 2 by looking at the other rectangle. So this other rectangle has this side labeled with the 3, so we know that from here to here is 3. And then they have from here to here is 5. So what plus 3 gives us 5? So that's how we know that this part must be 2. And then this rectangle has, like for this side length, 8 plus 2 would be 10. And then for confirming that this side length is 2, you're actually gonna have to look first over here that this longer side is 10. And that part of that long side, you know, like from the top to about here is 8. So if from here to here it's 8, what must here to here be in order to equal 10? 2. So that's how you obtain some part. So don't assume, usually they're not drawn to scale, although it kind of looks like it anyway. But the area is 20 square inches because area for a rectangle is what? Scale, third grade. Area for a rectangle is what formula? Length times width. Remember, your ACT Aspire will also expect you to know the formula for like area of a triangle, area of a cylinder, area of a triangular prism. So like make sure that, well, that would actually probably be volume, but area of a circle, like they expect you to know that. So make sure that we do. Um, by Tuesday next week. Look them up if you have to, make flashcards if you have to. But it shouldn't take that long to tell me that the area of a rectangle is found by length and width. Questions on that? All right, so then in figure B, we're missing this side length. Table 6, what is that missing side length? 9. And how'd you get that? Okay, what did you get for the top part of it? And I mean, they're not telling me, for example, that this whole piece is something. So how are you able to figure that out? Okay, so again, we're kind of assuming it's drawn to scale, and it's not necessarily. It is 4, the answer is 9, so I mean, it seemed to work for you this time. But you do have to use the other clues, because again, it might look drawn to scale, but that's not necessarily the case. So what you probably have to do, because right now, I mean, yes, we put a 4 there, but we can't assume. Right now, the only measurement you can readily figure out with what they did provide you is this side length. Because they give you the area of that rectangle and they tell you that one of the dimensions is 12. What times 12 will give us 60? So this side is 5 inches. Still not helping me get this one, but you'll see. What I'm going to do now is look over here. Now I have enough information to label what this side is. So I know that this side has from here to here 5, from here to here 3, so class is 5 plus 3. Which then can tell me what this section is. Because if my area is 48 and my side length is 8, what times 8 is 48? 6. And if you don't have that memorized, divide. 48 divided by 8 is 6. Now I'm starting to get there. Now I'm starting to get enough information. Because if from here to here is 6, that means from this edge to this edge must be what? 5, because 6 plus 5 would give us 11. And then now I have enough information to conclusively say that this side is 4. Because if I look over here, I know that from here to here is 12, because that matches what this says, right? So 12 minus 5 minus 3 is 4. And then now I have the area, I have a side length. So then 36 divided by 4 is 9. So yes, it is 9 inches. But that's hanging over here. Questions on that? Okay, so good like little puzzle, kind of think about that when we do stuff today. Think of it as a puzzle and it'll make it a lot easier. Because a lot of it is some guess and check. But of course there are ways, like for example, if you didn't know what times 4 gives us 36, divide 36 by 4 and it'll give it to you. But good little exercise. Today we are doing lesson 6 of unit 7, and it's called rewriting quadratic expressions in factored form. There's actually like 4 parts to this lesson that we'll learn over like this week and next week. So going from standard form to factored form is a big skill this unit. In the last unit, we mostly just went from factored form to standard form by multiplying. So we're gonna do a bit of the opposite. Kind of like if you were here yesterday, we did that Kahoot about factoring by BCF. It's like the opposite of distributing. So we're gonna do the opposite and we're gonna try and be in a different but we are gonna explain how the numbers in a quadratic expression in factor form relate to the numbers in the equivalent standard form. There is a pattern there. And when they are in the form x squared plus bx plus c, you can rewrite them in factor form. So this right here, you want to make a note of it. The reason why you don't see the a like you normally do in front of x squared is because they're making the a 1 for this lesson. When a is not 1, there are slightly different steps, really just like one added step usually. When I teach it to you, I'll still account for that added step, but just know like these examples are going to be a little easier because A will be 1 in this lesson. I'm recording right now, although the math doesn't typically change from year to year, so you can always catch up with whatever you miss in the video lesson in Schoology. The practice is lesson 6 in Schoology. Been reminding you of this. There's still time for you to make up any lost points from the exemplar test we did last week. And there's still time to increase your overall math levels in time for ACT Aspire, which is Tuesday. All right, again, it's a lot of applying math skills, so it'd be nice for you to like have the math skills to be able to apply it. And so doing these really help with that. And aside from that big test, which is on Tuesday, you do have a quiz this Friday over what we've covered so far in Unit 7. So if you've been absent, make sure that by Friday that you have those notes done so that you can use them for Friday's quiz. Questions? All right, and not sure if you saw my message on Student Square, but if you don't have Student Square, like you need it. Anytime I ever have to adjust my tutoring hours, I post it in there. So Friday, I'm not available, unfortunately. Miss Torres is available today after school, and tomorrow Miss Rodriguez is available for tutoring until 3 tomorrow. Okay, so right now, this activity. What expression does this first diagram represent? I don't love that they put a whole bunch of boxes. So just kind of pretend like there's no additional lines over here. We'll do this one together. We've seen this in the last unit. They're called our area models in order to multiply multi-term expressions. So this I know is a 2-term times a 2-term because of the way it's set up. My first parentheses will be x plus 2. And my second one will be x plus 3. And yes, you can reverse this order. You can put x plus 3 first. That doesn't really matter. But I know if they set it up like this must be the factor form. And if the plus sign is not written, we still assume it's positive. It's only negative if they actually put the negative there. Okay, so there's that. Then my standard form we would get from finding the area of each individual square on the inside. Remember? So we would do like x times x to get x squared, 2 times x to get 2x, 2 times 3 to get 6, and so on. Usually you have to combine like terms at this step. So I have a like term here and here. So class, let's 2x plus 3x. 5x, good. Even I was thinking 6x, but no, it is 5x because we're adding, we're not multiplying right now. And when we are writing our answer in standard form, we do separate the terms with plus and minus sign. So don't forget that. It's positive, so I can put plus 5x. The x squared doesn't have a like term to combine with, and neither does the 6, but it's positive, so we put plus 6 to show that. All right, questions? Bring back some memories. You can use area models for the thing we're about to do later. I'll show you a different way as well that I think is easier, but just refresh your memory on how these work. So now try this one. If this is the setup, what goes in each individual box? And what would be like my factor form and standard form? So kind of like this, but there's also some other parts missing. Give you about a minute or so. All right, table 8, what would have to go in this box? Good. Table 9, what would have to go in this box? Table 1, what would have to go in this box? Table 2, what would have to go in this box? And it's positive. You could put the plus 12 if you guys like. But usually if we don't put it, it's assumed it's big closer. So that's what we have to complete the area model. The factored form expression, table 3. Can you tell me what the factored form must have been if this is our model? So similar to what I wrote in black would be the factored form. That would be the factored form if it's set up like this. Okay, great. And then based on what I have here to make the standard form table 4, what's going to be my standard form for this? Plus 12, I think you mean? Yeah. Okay, good. Because we do have some like terms to combine, and those are like terms because they both have an x to the first power. So like terms have to have the same exact variable with the same exact exponent. And combine means add. So adding the numbers in front, how we get our middle term, and that's what we've been doing. So any questions on that? Does that make sense? Or, yeah. So that's also a way to check your answers to the thing I'm about to show you later. But you have some other problems that they want you to show diagrams for to prove that they're equivalent. That's really similar to what you're going to see on your final too. I believe that's like word for word a question on your constructive response part of your final this semester. So when they say use a diagram, they mean use the area model that we've been doing. So however you want to do it, set it up. I'll let you remember how to set that one up. But like the two terms we know creates something like this. Separate it by the terms. You can put the plus if you like. If that helps you. And then show that it's equivalent by showing it eventually becomes this. Do that for these 3. I'm going to freeze my screen. I'm going to do it myself. And then all you should have to do is check your work once I unfreeze. So one way to prove that expressions are equivalent is if you can manipulate one to get the other. So like multiplying out the factor form to get the standard form is a way to show that they're equivalent. And then just for like your personal self, you can also graph and show that they're equivalent if they produce the same exact graph. I wouldn't necessarily put that on like your final, because if it wants to diagram, it wants to see something like that. But I mean, that's a way to prove that something's equivalent, so it will at least get you some points. Notice that the first one was a single term times a 2 term, so that diagram would look a little bit smaller because you set it up by how many terms you 1 by 2, 2 by 2, and so on. All right, so review. Any questions on that? Now, this next part, we're just going to make an observation. So when you are multiplying these binomials, so this would be, it says product of 2 sums. This is the product of 2 sums. And product of 2 differences, and we're a product of 2 differences. See any like patterns that you might notice. So for example, I noticed that this last number in our standard form is always the product of these two numbers. Right? We always multiply those two, and they always give us our C value, right? That's true for this other one. When I multiply -5 and -1, I get a +5. So C always is a product of these two numbers when it's written in standard form and it's like simple like that. That's what I do. All right, what do we notice about like our B value? What is our B value always? Nice, we can open our eyes and pay attention to what we're saying. There's a pattern with the B value. So the number that's in front of the X, that number is always what? How can I always get that number? How do I end up always getting that number? What do I always do? I combine like terms. And combine means what in math? You add them. So this number in front of the X is always the sum of these two numbers, isn't it? 2 + 4 is 6. -5 plus -1 is -6. They wrote it like this to remind you that like X minus 5 and X minus 1 is the same as X plus -5 and X plus -1. It's still a sum, even though they have subtraction signs too, technically. You're still getting those two numbers by adding. So if you watch some other math videos, they might say that that's a shortcut. Like instead of just doing this area model, just know that it's always going to be X squared plus the sum of these two numbers and the product of those two numbers. It always ends up being that, at least when it's that simple factor form. All right, questions on that observation? Do we see that? It's always a sum and then the product. Because that's going to form the basis of this next activity, which is this one on the top. So we need to be able to go back and forth between the two forms. So in which you've done an activity similar to this in the last unit. So if it's factored to standard, just multiply. Do your area model, do your distributing. The standard form for this one is going to be X squared plus 7x, right? Down here, you could follow that pattern we just observed because it is like a 2 term times a 2 terms. We know that it always starts with X squared. That my next number is always the sum. So class, what is 6 plus 2? It's going to be plus 8x. And then our C value is always the product of those two numbers. What's 6 times 2? And again, you could do the area model, you could double distribute, but that is the answer. I just went off what we observed in the last one. So then for this one too, it's also like a binomial times a binomial, and it's like a simple one, not a complicated one. So I know it's going to start with an X squared. I know the next number is going to be the sum of these two numbers. So class, what's -6 plus -2? So this is going to be a -8x. And then my last number is always the product of these two. So it's -6 times -2. If you said it, I didn't hear you. +12. So that's going to be my standard form. All right. Now, the trickier part is going from standard to factored, but I'm going to show you a way that makes it easier. These first two standard to factored forms, think about what we did yesterday. These aren't going to follow the strategy without the code. Because these are a 2 term So in this, all you can really do is like by GCF. So I can't factor out any numbers. I can factor out an X from each. And what would have to go in the parentheses in order to multiply to get this? X plus 9, good. Right? And then you could distribute, even just in your head, it does give you x squared plus 9x if I were to multiply it. So that is my factoring point. Good. So then in this one, look for a GCF. I don't have one between the numbers, but I can factor out an x from each. What would I have to multiply by x to get this? X minus 8. Good. Questions on that? All right. So for these trinomials where a is 1, so all of them have just like a as 1 in front of the x squared. You can use what we call the diamond method, what you might hear called the AC method. You can also use an area model, but I just think they're less for this. But you can do them if you like them. We know that we need to find what gives the product of 12 and the sum of 13. So this is the way to organize that thinking process. You draw an X. The top will be whatever A times C is. So like for this one, 1 times 12, that's my A times C. 1 times 12 is 12. And then your B value will go on the bottom. So like B for on the bottom. And my B value is 13. And like I said, we're looking for two numbers that their product is 12 and their sum is 13. So think of all the ways you can multiply to get 12. No decimals though. So like, would 2 and 6 work? Would 3 times 4 work? Would 12 times 1 work? So really, it's kind of like a guess and check. It's kind of like a puzzle where you're trying to find two numbers that make the puzzle work, that multiply to the top and add to the bottom. So once you find the two numbers that make it work, you're going to write your factored form as something like this, where the signs of these numbers correspond with what they have to be to make it work. So I have a positive 12 and a positive 1. That's our factored form of lithium. Let's move on that. We'll do one more together, and then I'm going to have you try all of those. I feel like a lot of you are just like zoned out, don't care. There's like really no way to make it easier. It's just going to keep getting harder after this. So like tomorrow's lesson is an extension of this one. I need you to get the bare minimum of this. So, next one we're going to set up. Normally I just write it like this. So like the next one I would set up 12 on the top, -7 on the bottom. But I would recommend, until you know how to set it up by heart, write all the labels. The top is always A times C, so 1 times 12. The bottom is always your B value. And we're looking for two numbers that multiply to 12 and at the same time add to -7. Don't say them out loud. Just think about it. Two numbers that multiply to 12 but add to -7. So table 5. What two numbers multiply to 12 that add to -7? If you get stuck, think of all the ways you can multiply to 12, but don't like no decimals. Okay, do 12 times 1. There's no way I could mess around with the signs on that to add to -7, so no. Do 6 times 2, again, no way I could add or subtract those to get -7. Do 3 times 4, and I can't think of any others that multiply to 12. Could I mess around with 3 and 4 to add to -7? How can I make it add to -7? Just one of them? Both. Because if it's also multiplying to a positive, they would both have to be negative. All right, so if it's multiplying to a positive, adding to a negative, you know they both have to be negative. So then right here, that would become x minus 3 in parentheses and x minus 4. That's my factor form. And have you try the rest using this method. Or you could just think, some teachers have them just say, oh, think of two numbers that have the product of this and some of this. I don't work that way. I have to like make it a puzzle and guess and check until I find the one that works. All right, Jake, you're on deck, so make sure you know how to do it and can explain it. So, table 8, we're going to do this next one. So we're going to set it up. What did you say, though, for your factored form, table 8? Okay, so let's see. I think this is the easiest method. There's lots of methods out there. This one has the same setup each time. Do A times C, so 1 times 9, put that on the top. The B value, put it on the bottom, and the signs do matter, like they're both positive. I'm not writing the sign because it's assumed to be positive if you don't write it, but I need two numbers that multiply to 9 and at the same time add to 6. Table 8 said 3 and 3, both positive, and that does work. So yes, that is my factored form for that one. You can also write it a little more condensed too, like this, only because they have the same exact parentheses. So you can write it as just x plus 3 in parentheses and squared. Good on that one? All right, Jake, the next one. You have it in factor form? Okay, well then let's set it up. If we're setting it up like this, what would A times C be? What's the number in front of the x squared if it's not written? No. What's this number if it's not written? If it was a 2, we put a 2 there. But since I didn't write anything, what must be the number in front of the x squared? Okay, so my A is 1. A is always in front of the x squared. My C value is what? What's 1 times 9? Okay, that's how I'm going to set it up. The top is always A times C. B, which is always my in front of the x. What's my B value? That's going to go on the bottom. That's how you set it up. That's how you set up your little puzzle. And then we're looking for two numbers that multiply to the top and add to the bottom. So two numbers that multiply to 9 and add to 10. Jacob, you know when you think you know it? Two numbers that multiply to 9 and at the same time add to 10. One and what times 1 gives us 9? Okay, does 1 times 9 give us 9, class? Does it add to give us 10? So then we found it. So they both have to be positive, and we write it like this, showing that the 1 and the 9 are positive. All right. Eventually, we will have an A value that's not 1, and there will be like one added step that you do. But right now, today's lesson is kind of easy because A is 1. Okay, so it's still A times C on the top, B on the bottom. Table 9, you're going to do the next one. What, did we get the factor form for this one? What did you get? X minus 9, you said? Okay. So let's see, the way that I would set that one up is I'd put 9 on top, negative 10 on the bottom. They're saying that negative 1 and negative 9 make it work. Do you guys agree? Do they multiply to positive 9 and add to negative 10? Good, then that's right. Table 1, you'll do, or table 2, you'll do the next one. X squared minus 6x plus 9, what did we get for the factored form? Okay, let's see. That one I would set up. I know I'm kind of writing all over, but hopefully you know how to set it up now. That one I would put the 9 on top, negative 6 on the bottom, looking for two numbers that multiply to 9 and add to negative 6. So they're saying negative 3 and negative 3 accomplish that. Do you guys agree? All right, that is correct. You can also write that one condensed as well, because it's the same exact parentheses. You could just write it as 1 and squared. All right, the last one, the one with the variables that always like trips people up. They're just showing you that thing we observed earlier, basically. But you could set up, even try with the diamond method. 1 times mn is mn, that's my A times C. My B is m plus n. So class, what can we multiply to get mn and add to get m plus n? What times what will give us mn? M times n, right? Those multiply to give me mn, they add to give me m plus n. So my factored form for that last one would be x plus m times x minus n, or not minus n, plus, I don't know why I did that. They had to be positive to make it work, so they both have plus signs in front of them. Questions on that? All right. So now apply that to the cool down. The cool down has some blanks for you to fill. So again, all the observations we made, all the ways that you could multiply or now factor, you know how to factor now. At least some of the setups you know how to factor. Remember, this is always our product of these two numbers. And this was our sum when it's a trinomial and it's real simple where A is 1. So try the cool down. I'll make sure I project the answers to the cool down in a couple minutes, maybe 3 minutes. So don't put your notes away yet. When you do finish the cool down and you're ready to do your practice, go ahead and do that. Okay, so this is a solution to the cool down. So I mean, going from factor to standard, you could have just multiplied it like we've done before. But also, when it's really simple like this, we know that the B term is the sum and the C term is the product of these two numbers. So I just filled it in based on that. Now for the rest, going from standard to factored, they gave you some parts for some of them, but even if they didn't, it would still be these two numbers. Like it can never be multiple answers of other factors. So for number 2, I set up my diamond. I multiplied or I figured out what multiplied to 14 and added to 9 was a positive 7 and positive 2. They already gave me the 2, so I know this blank has to be the 7. This is similar to what will be on your quiz, filling in blanks. Number 3, I looked for two numbers that multiplied to 10 and at the same time added to negative 7. Negative 2 and negative 5 do that. Now, notice I didn't write negative 5 here because they already had a negative. So if it was plus, like on your quiz, if you know the answer should be negative, but they put x plus blank, then yeah, write negative 5. But this one, they already had the minus, so I'm not going to put the minus again. And then lastly, setting it up, looking for two numbers that multiply to 20 and add to negative 9. At first, I tried like 2 and 10, but there's no way to add or subtract those to get a negative 9. So then I thought of other things that multiply to 20, like 5 and 4. If they were both negative, that's how it adds to a negative and multiplies to a positive. Notice they gave me minus signs already, so I'm not putting the minus sign again. Only if it was like x plus blank would I put the minus sign to show it. Questions? Good. Okay, you still got some time. You don't got to pack up yet. You could work on your practice a little more, maybe even finish it.